Every AI you talk to has amnesia. You had a real conversation with your AI yesterday. You figured something out together. You close the tab. Next session walks in completely fresh. No memory of it. Nothing. Your grandkids are going to laugh that we lived like this. And the reason it happens is not what you think. It is not the model. I built this stuff and I had it backwards for a long time. So what I actually do is build memory for AI agents, making them remember you across sessions, recall the right thing at the right time. And for a long time, every time an agent forgot something, I blame the obvious stuff. The model is not smart enough. The embeddings are bad. The vector database is weak. Then it slowly dawned on me that all of us are doing something strange. We are faking memory in software on top of hardware that was never built to remember anything. Here is the thing almost nobody points at. In a normal computer, the memory and the processor are two separate places. To think a single thought, the machine drags data from memory over to the processor, does a tiny bit of work, and ships it back billions of times a second. There is even a name for this, the von Neumann bottleneck. Your brain does not work like that at all. In your head, the thing that stores the memory is the same thing that does the thinking. There is no commute. And the cost of that difference is wild. Your brain runs on about 20 watts, a dim light bulb. The data centers we use to train AI pull enough power for a small town. We are about a million times less efficient than the thing in your skull. So the question that grabbed me was, what if the problem was never the software? What if we need different physics? Which brings me to the strangest story I have read in a while. 1971, a young professor named Leon Chua. Every electronics textbook at the time said there are three basic building blocks in any circuit: the resistor, the capacitor, the inductor. Settled science. End of list. Chua looked at the math, at the symmetry of it, and said, no, there should be a fourth one. And he could describe exactly what it would be. It would be a component whose resistance depends on its own history. The more current you push through it, the more it changes. And when you stop, it stays changed. That remembers what you did to it. He called it memristor, memory plus resistor. And then, in the same breath, he admitted he had no idea how to build one. So, for almost 4 decades, the idea just sat there, a neat piece of math, a curiosity. People mostly forgot about it. Then, 2008, a team at HP Labs, led by a guy named Stan Williams, and here is the part I love. They were not chasing Chua's idea. They were building tiny experimental switches and kept seeing this weird behavior they could not explain. They had data, no theory. And the way Williams tells it, the breakthrough came when he had a serious car accident and got stuck in bed for a month. Out of boredom, he read old papers and he found Chua's. He realized Chua's math never actually required magnets, the way everyone assumed. It was pure math. Any material that behaves this way is the missing element. So he wrote Chua an email basically saying, we found your memristor. We built it. It works. 37 years later, Chua said he was shocked but not surprised. Because in his words, a law of nature is always there. Someone was always going to find it. Now, here's the part that actually stopped me when I understood it. Go back to 1949. A psychologist named Donald Hebb writes one line that becomes the foundation of modern neuroscience. I, in fact, started my project, Heads.ai, inspired by him. Neurons that fire together wire together. Meaning, your brain learns because the physical connections between neurons get stronger the more they are used. The memory is not filed somewhere. The memory is the change in the connection itself. Now read Chua's memristor back, a device whose resistance physically changes based on its own history of use and stays changed. It is the same sentence. A memristor is not a model of synapse. It is a synapse in silicon. We did not design it to copy the brain. We did the math, built the part, and discovered we had built a brain cell. Okay, so why does a brain cell in silicon matter for the AI on your screen? Remember the bottleneck? Memory here, processor there, data commuting between them, and burning power? Memristors break that. Arrange them in a grid called a crossbar, and because of the physics, one electrical pulse through that grid performs an entire matrix multiplication at once in analog without moving any data anywhere. And matrix multiplication is basically all an AI model does. So sit with that. The memory is the computation. That is the entire game. No comment, no bottleneck. There is one more thing. A normal memory cell stores a 0 or 1. A memristor can hold an analog value up to about 1,000 different levels in a single device. And AI does not need perfect exact numbers. It runs on approximation. So an analog approximate low power part is not a downgrade for AI. It is a near perfect match. Now the fun twist. When the Memristor was first built in 2008, everyone got excited for the wrong reason. They thought it would replace all computer memory, one part to rule them all. That flopped. Now, a jack of all trades loses to a specialist, and a regular memory is really good at its job. But here is what actually happened quietly. Hundreds of millions of chips already ship with memristors inside them right now. For storing firmware, configuration, boring stuff, nobody markets it. So there is a decent chance you own a memristor at this point and have never once heard the word. If it had a hype cycle that died, why do I take this one seriously? Two reasons, and they are not vibes. One, the biggest chip factories on earth, TSMC, Samsung, have already built memristor technology into their standard manufacturing. That is not a lab demo. That is the supply chain voting with its money. IBM, Intel, and startups like Tetramem are shipping chips aimed at AI inference. Two, a research lab in Edinburgh showed a memristor chip recognizing a handwritten digit using roughly 1,000 times less power than a GPU, doing the same task, not twice as efficient, 1,000 times. And now I have to be honest with you, because the whole point of this channel is that I do not sell you fairy tales. This is not in your laptop, and it will not be next year for real engineering reasons. The devices are inconsistent. Two of them on the same chip behave a little differently. They wear out after enough writes. Manufacturing yield is low, analog is noisy, and going from a lab chip with a few thousand of these to a real chip with billions of them is a genuinely brutal problem smart people have been grinding on for over a decade. So I'm not giving you a date. Progress here is real, but it is slow. Anyone who tells you neuromorphic chips are about to replace your GPU next year is selling something. There is one last thing Chua said that I cannot stop thinking about. He insisted the memristor was not invented, it was discovered. His example was nobody says Columbus invented America. It was already there. He just got to it. Chua believed the memristor was a law of nature, sitting in the equations the whole time waiting. And he had a line about why nobody believed him for 40 years. He quoted the physicist Max Planck that a new idea does not win by convincing the people who disagree. It wins when they retire and the next generation grows up with it as normal to be proved. He waited 4 decades to be proven right. And it genuinely did not bother him. Because the law of nature is always there. Someone always finds it. So here is where I have landed, sitting with all of this. For about 50 years, every single thing we have built for AI memory has been a simulation. We fake memory with search. We fake it with databases. We fake it with clever software loops. And it all runs on hardware that fundamentally was not built to remember. Fighting that bottleneck the whole way. Memristor is the first time we have a piece of hardware that does not simulate memory. It just remembers the way a synapse does. Because physically it is the same kind of thing. I do not know if it is 5 years out or 20. I genuinely do not. But the direction stopped feeling like a question to me now. So the next time your AI forgets the thing you told it 5 minutes ago, I want you to think about this differently. It is not broken, it is early. We are still building the part that remembers. A guy did the math on that part in 1971 and got told it was nonsense for 37 years. So here is my honest question for you. What is something everyone agrees is impossible right now that you quietly think it is just early? Tell me. I want to hear the one you would bet on.